Today we are going to move on from yesterday, and yesterday we stopped at what? Propositions. Yeah, we started talking about logic, and the first step of logic was to define what a statement is, and the next step from statement was a proposition. A proposition is a statement that is
either true or false.
yes, it's either true or it's false, but it's not both simultaneously. Okay, and we saw a few examples of that. So that's the ground where we are starting, right? We have defined something that is either true or it's false. So we can now categorize these two things, right? Truths and falses. Okay. The next step is going to be to construct new statements from a given set of statements. Okay. So we have proposition. We have a list of propositions. Okay, how do we construct new statements from those given statements? Okay, one thing from here onwards, I would use the word statement and proposition alternatively. They don't mean the same thing, but from now on, whenever I say statement, I mean a proposition. I mean a statement that's either true or false. Okay. Good. So the next step of our journey is to construct more statements from a given list of statements. And how do we do that? Yeah, we define some operators, and we use those operators to construct compound propositions based on a given set of propositions. Okay. So this is where we were yesterday. Yeah. Okay. Okay. All right. Logical operations, and the goal of logical operations is to what? That we have given set of propositions and we want to construct more propositions. Okay. So, for example, I have a proposition which says it is raining, and I have a proposition which says that it is cold. It is raining and it is cold is another proposition. Okay, and we could say that this is a compound proposition because it is compound of two other propositions. Okay, what determines the truth value of this compound proposition? So there are a set of rules which define what is the truth value of the compound proposition based on the truth value of the original propositions. Okay, so what that says is that if you know the truth value of the original statements, you must be able to figure out the truth value of the compound proposition. Okay, are you with me?
Yes.
Okay, cool. Let's see some basic rules, and here are the rules for the AND. एंड को हम फॉर्मली कंजंक्शन ऑपरेटर कहते हैं. Okay, so it's a conjunction operator. We are conjuncting two different propositions. Okay, we'll denote propositions with we'll use some algebra. Okay, so we'll use one proposition name as P, and the other proposition would be denoted by Q, and the conjunction of P and Q would be denoted by P and Q. This thing is called logical AND. Let me lick now, so this is wedge, and you read this as P and Q. Okay, and this is their truth table. Okay, this tells you that if both P and Q are true, then P and Q is definitely true. Okay, in all other cases, P and Q is false. Okay, so for P and Q to be true, you need both P. You need P to be true and Q to be true. Okay, I'm using the word and multiple times. Anyhow, so if you have statement P which says that it is sunny, and your statement Q which says that I go to the beach, P and Q says that it is sunny and I'm going to the beach or something like that. Okay, awesome. Are we good? Questions? Good. We logically have a disjunctive operator as well, or the OR operator. So an OR operator is true when either of P and Q is true. Okay, if P is true or Q is true, then P or Q is true. Okay. You invert the AND operator to get the logical OR operator, and here's an example. If P represents I found a unicorn and Q represents I won the lottery, then P or Q says that either I found a unicorn or I won the lottery. Okay? Are we good? Okay, moving on. The third operator that we're going to use is called the exclusive OR. Exclusive OR, in my view, is actually what we usually mean by OR in daily life. Okay? We'll see the example in a moment. So exclusive OR says that, well, the inversion of exclusive. No, scratch what I just said, okay? But I have something similar to say in a moment, okay? All right, so exclusive OR is true when the original two statements have different truth values, okay? So if both of them are either true or both of them are either false, then exclusive OR will be false, okay? We don't want both of them to have the same truth value, okay? So if one of them is true and the other one is false, then you will have a true for the exclusive OR statement, okay? So we read it simply as P exclusive OR Q, and here's an example. If P represents I am in mood for pizza and Q represents that I am in mood for sushi, then P exclusive OR Q represents this. Either I am in mood for pizza or sushi, but not both. Okay? And that's, if you look at this example, if you were to say this in common language, you would not say the last part. The last part would be implied by your conversation. Okay? When I say that, okay, I'm gonna go for a pizza or sushi, then it's implied in the language that I'm not gonna go for both. Okay? But the way we are defining the logic, we are scratching that possibility explicitly by using exclusive OR. Okay? यहाँ पे अगर मैंने simply OR use किया होता, तो that would have allowed me to go for both of them. Okay? So keep that in mind. That's the difference between our common tongue and what we write in logic. Okay? So if I ask you on exam to write a statement for this part, okay? I'm in mood for pizza or sushi, you would write P or Q. Okay? But that allows the possibility that both P and Q are true. Okay? Are we on the same page? That actually confuses people, because at this point we are kind of diverging from the kind of normal meaning of OR. Okay? This OR is different from the OR that we use in the normal tongue. All right. The fourth operator is the negation operator. We read it as not. Okay, this is kind of 270-degree rotated L. Okay, so yeah, 270-degree rotated L clockwise. So negation means that you would just take the opposite of the statement. Okay, if the statement is true, the negation would be false. If the statement is false, the negation would be true. Okay. So for example, if P represents that it is weekday, not P represents that it's not weekday, it's weekend. Okay. All right. So we saw 4 operators so far. Okay. And, or, exclusive OR, and not. Okay. And I assume that you would be able to construct these truth tables. Okay. Have you constructed these truth tables in high school?
Yes.
Before? You have?
Yes.
Okay. Okay, nice. Cool. Okay, then it's gonna be a breeze for you. Do we have a worksheet today? We don't? Okay, cool. So let's do this now. Okay? Let's see what it means. So the problem one says that if I find my keys is represented by P, okay, so it's a statement. I am late for work is represented by Q. How would I represent I'm not late for work and I found my keys? Raise hands. Yeah.
Negation operator P and Q.
Negation operator P, which says that I am. No.
Collectively negate B and Q.
Okay. I'm late for work. The first one says that I find my keys. Yeah, go ahead.
Both the statements are false and we will use AND operator.
Okay. So the answer would be. No. So see, the thing is, you don't tell me whether this thing is false or not. You tell me how do I write it down as kind of conjunction, disjunction, negation, or exclusive OR operator based on P and Q. Okay, I have P and I have a Q statement. Now I have a bunch of operators that I can use to make another compound statement which represents this statement. Okay, this is a compound statement, right? Yeah. P disjunction Q. See, P disjunction Q would be that P says that I find my keys. Okay, so P is I found my keys or I am late for work. Okay, so P disjunction Q would be that I found my keys or I am late for work. But that's not what I am saying here. Okay.
Exclusive OR.
Or you would use exclusive OR. I think not. Yeah.
So negation Q and P.
Negation Q and P is the answer. See, the thing is, look at the first part. The first part says that I am not late for work. This is just the negation of Q. Okay? The Q says that I am late for work. So the negation of Q would say that I am not late for work. Okay? Then I use AND operator. Okay? Over here. And then I say I found my keys. Okay? When I say I found my keys, I'm just saying P. Okay? So it's the negation of Q and P. All right? Are we on the same page?
Yes.
Good? All right. Let's move on. The second problem. P is it's raining and Q is that I forgot my umbrella. And I want to write down it's not raining or I forgot my umbrella. Yeah. Yeah.
Sir, not P or Q.
Not P, yes, or Q. Yeah, that's quite simple, right? It's the negation of the first statement, and there is an OR operator, and then I would say that I forgot my umbrella. Okay, which is Q. All right. Awesome. And again, note that यहाँ पे जो OR use हो रहा है, this OR is not the usual OR. Okay, this is the OR in the logical sense. Okay, this OR allows the possibility that both of these statements are true. Okay, all right. Third one. Suppose P is I have cookies and Q is I have milk, and I want to write down I have cookies and milk. Absolutely. This is simple conjunction. I would just say P and Q. All right. I hope everyone is on board. If there are any complaints, now is the time to raise your hand. We didn't see an example of that. We'll see at some point. Okay. Cool. So these are the solutions, and you guys figured them out on your own. I think I have another example. Yeah. How about this? So P and Q are two arbitrary propositions. Okay. You don't know what P represents. You don't know what Q represents. Can you see the screen from there? You cannot. Can you move over there? All of you. I don't know. Yeah, go ahead. There are 3 seats over there. Go sit there. Don't do this. Come on. This is not fair. Go ahead. I can hardly see from here. All right. So the question says that when will this thing happen? What kind of truth values for P and Q would make sure that this happens? Okay, so I want a condition on the truth value of P and the truth value of Q that will make sure that P. Are you part of this class? Are you part of this class?
Yes, sir.
You're too late. No, you're not supposed to enter after 5 minutes. Please leave. Please leave. Let's meet next week. All right. So this statement says that P exclusive RQ is not equal to P or Q. When will this happen? when will P exclusive or Q would be different from P or Q? Yeah.
When both P and Q are true.
Yeah, that's actually the answer. So think of all possible things that could happen with P and Q. When P and Q are different, one of them is true, the other one is false, then they are same, right? In those cases, we would get that P exclusive or Q is true, and P or Q would also be true. The other possibility is both of them are false. If both of them are false, then this thing would be false, and this thing would also be false. Okay, so that's not the case either. The only case that's left is when P and Q are both true. Okay, when they are both true, P or Q is true. Okay, but P exclusive or Q is not true. Okay, so the way to solve this is to look at all possible combinations. Okay, so there are 4 possibilities for the truth value of P and Q. And for each of them, you check whether they are equal or not. And there is only one possibility where they are not equal. Okay? And that's when both P and Q are true. Are we good? Yes. All right, let's look at the second one, which says that P or Q is equal to P and Q. Yeah, P and Q is only true when both of them are true. And in that case, P or Q would also be true. In all other cases, in all other cases, P and Q would be false. But what if both of them are false? उस केस में भी तो ये true होगा, right? All right. So this is true when both of them are false or both of them are true. Okay. Okay. Cool. Yeah, we missed that. So when both of them are false, then they are equal, right? All right. The last one. P exclusive or Q and is equal to P and Q. Okay. When both of them are false. Okay, let's see. I haven't figured that out yet. Let's see. So when they are different, this would be true and this would be false, right? When both of them are false, this would be false and this would be false. That's the one case. And when both of them are true, this would be false and this would be true. Okay, so the only case when these are equal is when both of them are false. All right, are we on the same page, everyone? Okay. Okay, so for the second answer is not complete. When both P and Q are false, this is also equal. Okay. Moving on. All right, we evaluate the compound proposition with logical operators in a specific order. If you switch the order in which you evaluate or think about a statement, compound statement, you will reach at different truth tables. Okay, you will get different truth values about them. Okay. So what we do is we usually evaluate the parenthesis first. Okay, so we have things in the parenthesis, we evaluate them first. After that, we evaluate negations, pair conjunction, then pair disjunctions. Okay, so parenthesis, negation, conjunction, disjunction. Okay. All right, let's see an example. So we have P and not Q or. Okay, so in this case there are no parentheses, which means that the next thing we do is we evaluate negation of the Q. Okay, so what is Q? Q is beach. So not Q would be not at beach. उसके बाद फिर we evaluate this conjunction, which is P and not Q. What's P? P is sunny. So sunny and not beach. उसके बाद we evaluate the or operator or the disjunction operator, and we will get sunny and not beach or umbrella. Okay, so stupid statement, but this is what it means. Can you guys fill up this truth table? I can help you fill few columns for you. Okay. So when you arrive at a compound statement, you evaluate parts in that particular order. Okay, you evaluate, for example, you would start with all possible values of the original simple statements, and then you would evaluate what is in the parenthesis, okay, and then move on, then the negations and so on. Okay, so you already know how to evaluate P or Q, and you already know how to evaluate P and Q. The next step is to evaluate the negation of P and Q. So what's the negation of P and Q? Yeah, you would get a false here and you would get true everywhere else. Okay? Awesome. And what would be the end of these two? So iska end karne ke liye what you would do is you would consider these things, these parts, okay, P or Q, and negation of P and Q as the simple statements. Okay, so unki aapke paas truth tables hain. This is true and this is false, so this would be false, and this is true and this is true, this would be true, and this is true and this is true, this would be true. This would be false and true, and this would be false. Is this recognizable? Do you recognize this truth table?
Yes.
What is it? Yeah. So see, this statement is actually the definition of exclusive OR. Okay? Exclusive OR between P and Q is equal to disjunction and conjunction with the negation of their conjunction. Okay? That's the kind of problem you will see on the quizzes and homeworks. Okay? So exclusive OR is equal to disjunction of two statements conjuncted with the negation of the conjunction. Okay? It's a mouthful, but let me say it again. I mean, it's written over there, I'm just pronouncing it. It's the disjunction conjuncted with the negation of their conjunction. Okay? So we are taking disjunction, we are taking conjunction, isko negate kar rahe hain, फिर then we are conjuncting. Okay? That's actually exclusive OR. So what that means is, what does it mean? It implies that you don't need exclusive OR as a fundamental operator. Okay? You can construct your own exclusive OR. Okay? अगर exclusive OR आपकी language में ना होता, तो you were able to construct exclusive OR on your own. Okay? You didn't need to define exclusive OR. You could have defined it on your own. Okay? So that's a nice thing to note here. Are we on the same page? All right. Yeah, so that statement written again. All right, next step in our language is the conditional operator. Okay, what is a conditional operator? Conditional operator says that you have two propositions. Okay, maybe simple, maybe compound. We don't care, but the truth table of one of those impacts or implies the truth table of other one. Okay. All right, that's the conditional operator. That the truth table of one is conditioned on the truth value of the other proposition. Okay, so we read this simple conditional proposition as if then P. Okay, so the most important part on this slide is that this thing itself is a proposition. Okay, keep that in mind. This thing itself is a proposition, which means that this thing is either true or false. Okay, this thing need not always be true. The mistake people make is they assume that if P then Q is always true. It need not be. Okay, this is itself a proposition, which means that it can be false. All right. Okay, moving on. So if P then Q means that it's defined by truth table, जो मैं आपको एक मिनट में दिखाता हूँ. What it means is that if P is true, then Q is guaranteed to be true. Okay? That's what this statement is saying. And this statement could be wrong. Again, I said this could be false. But this is what the statement is saying. That if P is true, then Q is guaranteed to be true. Okay? So keep that in mind. If P then Q means that if P is true, then Q is guaranteed to be true. And how do we represent that in the truth table? What do you think would be the truth table of these things? Let me give you the possible values, and then you can tell me whether this is true or not. When both P and Q are true, then it must be true, right? When P is true and Q is false, then it's false, right? Then this statement जो मैंने guarantee की थी वो नहीं रही, right? I was guaranteeing that if P is true, then Q is true. That guarantee is now false. Now the statement must be false. When P is false and Q is true? Okay, let's take a vote. People who think this is true.
When P is true and
When P is true and Q is false. Sorry. No, it's the other one. If P, so वो तो हमने अभी देख लिया ना. If P is false and Q is true. Okay, so you guys say that's true. And what about when both of them are true? Both of them are false. Then it's true. Okay, good, awesome. We'll see the explanation of these two statements in a moment. But that's what the answer is. Okay, that this thing is only false when the condition is true and the promise is false. Okay. All right. As an example, if x is a positive even integer, then x is divisible by 2. Is it a true statement? Yeah. So that's the definition of even numbers, right? It's true. If x is not a positive even integer, then x may or may not be divisible by 2. So I'm saying is what? What happened? Let's read it again. So it says that if x is not a positive even number, then x may or may not be divisible by 2. Is it true or false? It's vacuously true. I'm not promising anything. I'm saying this could happen or this could happen. Right? The statement is true. A conditional proposition is false only when the premise is true and the conclusion is false. Okay? यहाँ पे दो definitions हैं जो मैंने mark नहीं की. But remember, the first part of the conditional is premise. Okay? And the second part is the conclusion. Okay? Keep that in mind. Should I move on? Yes? Questions? All right. So, the statement that the condition is, if the conclusion is true, regardless of the hypothesis part, the conditional statement is trivially true. Okay? If the conclusion part, the Q is true, उस केस में I don't even need to look at P. Okay? Right? So if the conclusion is always true, I don't even need to look at the premise. Okay? क्योंकि जो चीज़ promise की जा रही है, that's true. So the statement would always be true. Okay? इसको हम कहते हैं this is trivially true. Okay? Does this make sense? Yeah, here's an example of this. If I make a promise that if you score more than 90, you will get an A. Okay? If at the end of the course you get an A, you don't need to worry about whether you scored more than 90 or not. Right? Because I delivered on my promise. Regardless कि आपको वो 90 score है या नहीं है. Okay? The statement is trivially true if you got an A. Okay? There is a similar statement to make. Here's an example. It says that if elephants can fly, then 2 plus 2 is 4. Since 2 plus 2 is always true, I don't need to worry about whether elephants can fly or not. Okay? I would say the statement is always true. This conditional is never false. All right. Yeah, since the conclusion holds, I don't need to worry about the premise. Okay? इसलिए हम इसको कहते हैं कि this is the statement, this conditional is trivially true. Okay? Okay? There's another way to figure out a conditional is always true, and that's called the vacuously true conditional. This is when your hypothesis is false. Okay? If your hypothesis is false, you don't need to worry about whether your conditional proposition conclusion is true or not. Okay? Because the conditional की एक requirement थी. अगर वो requirement पूरी नहीं हुई, तो फिर आप ये नहीं कह सकते कि promise true नहीं है. Okay? So again, if I come back to the same statement, if you score more than 90, you will get an A. If you didn't score more than 90, then this promise is always true. Right? The promise would have been activated if you scored more than 90, right? The promise is not even activated, which means the promise is viciously true. Okay? Are we on the same page? Yes? No? You're not? Okay, so what I'm saying is, जब आपके conditional का hypothesis false हो जाए, तो जो conditional किसी ने दिया था, आप उसको false नहीं कह सकते. Okay? So he made a promise कि if this happens then I will do this. अगर वो premise ही true नहीं है, तो फिर आपको नहीं कह सकते कि आपका जो promise था वो गलत था. Okay? That's what it's saying. Okay? Cool. So here's an example. It says that if unicorns exist, then 1 plus 1 is 3. This statement is true viciously because unicorns don't exist. Right? If unicorns don't exist, then there's no given कि ये वाली चीज़ true होनी चाहिए या नहीं होनी चाहिए. You guys think? If P then Q, is it equivalent to Q then P? It's not. Okay? These are two different statements. And here's an explanation. P then Q means that if P is true, then Q is true, and Q then P means that if Q is true, then P is true. These two statements have different meanings and can have different truth values. Here's an example. If I say that so P then Q says, for example, that if it's raining, I carry an umbrella. Okay? If it's raining, I carry an umbrella. That does not imply that if I carry an umbrella, it would definitely be raining. Okay? So keep that in mind. These two things are not same. I mean, this is a valid statement. This is a valid proposition. If Q then P is also a valid proposition, but it's not equal to P then Q. Are you good? If the truth value of P then R and Q then R always the same as truth value of P or Q then R. Go ahead, make a truth table and let me know. I thought we were going to have a worksheet today. No? Sorry, what?
Conditions of rate conditions.
Oh yes, absolutely. So you would have 8 rows there. There are 3 base propositions, P, Q and R. You would get 8 possible combinations. It is true? Okay, why don't you make a truth table? Let's make a truth table. So you're right, the statement is true, but for this part of the course, I want you guys to be able to make truth tables. Okay? That's for a week or so. For now, the answer is yes. Without looking at the truth table, let's see how you can figure out why the answer is yes. Okay? So for the first statement, if you look at the first statement, the first part is saying that P guarantees R. Okay? If P is true, then you're guaranteed to get R. The second part says that Q guarantees R. Okay? So these are two things which guarantee R. Okay? P guarantees R and Q guarantees R. Which means that if either one of them is true, you are guaranteed R. Okay? And that's exactly what the last statement is saying. That P or Q guarantees R. Okay? So you should be able to, just looking at this before you make your truth table, be able to see that these statements are actually equivalent. Okay? I think I have a truth table somewhere here. Yeah, this is just what I was explaining to you. Alright, so you make these, you know how to make these 8 combinations, right? Okay, so after doing that, you start by what's in the parenthesis. Okay, so in the parenthesis you have P then R and Q then R. And this is P then R. P then R would only be false when P is true and R is false. Okay, so you would get 2 rows where this is false. Q then R would also be false when Q is true and R is false. This is one of those and this is the other one. Okay, so you get this. Uske baad next is just a conjunction of these two. Okay, and this part is, for this part you also need P, R, Q, जो मैंने यहाँ पे नहीं बनाया. Okay, but you need a separate column for P or Q. then R. And this would only be true, sorry, this would only be false when this part is true and R part is false. Okay? And you'll see that these two are actually the same columns. Okay? Awesome. Questions? Are we good? Okay. All right. So there are different ways in which we say the same statement, which is if P then Q. Here's one which says that P is sufficient for Q. Okay? Right? जिसके लिए मैं भी word guarantee का भी use कर रहा था. Okay? If P is true, then you don't need anything else to be true for Q to be true. Okay? So you say that P is sufficient for Q. Sufficient is a key word here. Okay? You're going to have to remember the word sufficient here. Okay? The second part is Q is necessary for P. What does that mean? That means that if P happens, then Q will necessarily happen too. Okay? So Q is kind of a necessity. ऐसा नहीं हो सकता कि P true हो जाए और Q true ना हो. Okay? Q is necessarily true when P is true. Okay? We said P only if Q. Do we say that? Okay, I'm not sure about the last one. Let's scratch that for now. Okay, I'll come back to you. But remember, अब ये वाली जो चीज़ें हैं पहली दो हैं, इनको आप reverse नहीं कर सकते. So, for example, saying that Q is sufficient for P is not true. Q is not sufficient for P. Okay, when I say if P then Q, then P is sufficient for Q, which means that you don't need anything else apart from P for Q to be true. Okay. But if I were to say that Q is sufficient for P, that would mean that when Q is true, then P is definitely true. That's not the case. Okay? Similarly, second statement में Q is necessary for P is you cannot switch their places. Okay? P is not necessary for P. Q. Okay? I want questions? Confusions? For the first two part at least. So देखो, when I say Q only if P, what that means is that Q is true only if P is true. That's not what I'm saying when I say if P then Q. Q could be true without P being true. Okay? What this is trying to say is that P is true only if Q is true. Okay? That's what I mean by if P then Q. Okay? So this statement is saying if P is true only if Q is true. Okay? What that is saying is that if Q is false, you cannot have P to be true. Okay? That's kind of all this requires is a rephrasing to be able to understand this. If P is true only if Q is true is saying you cannot have P true and Q false. Okay? Okay? It's a kind of a mind twister. But let me say it once more. If P then Q is saying P is true only if Q is true. Okay? ये तो मैंने ये वाली statement repeat की. Okay? इसकी जो rephrasing है वो ये है, you cannot have P true if Q is false. Okay? So keep that in mind. You cannot have P true if Q is false. Yeah, you can say that. Okay? But we will come to that in a, I don't know, couple of slides later. But for now what I'm saying is, this statement is saying that if you cannot have P true and Q false. Okay? P would be true only if Q is true. Okay? Okay? All right, spend some time on it. Okay, let's rewrite these statements. Use some other words. Okay, but these are the key words that we are going to use. Okay, you should be very versed with these. We'll use sufficient a lot. We'll use necessary a lot, even after we move away from logic. Okay, so you should be able to understand this is what it means. Okay. Okay, all these statements describe the same implication, a relation between P and Q. The statements explain different aspects of the implication, but they are logically equivalent. Here's the kind of an example of the sufficiency condition. If the sufficient condition is true, it is guaranteed that the conclusion must be true. Again, if P then Q. Suppose we have an exam with the following rules. If you score more than 80%, you will pass the course. Here, scoring 80% is a sufficient condition for you to pass the course. Okay? The way to remember is to find an example that you can stick in your brain. If this is the example that sticks in your brain, go with it. Okay? You'll use sufficient. So the sufficient condition for passing is an 80% score. Okay? Cool. So it's, for example, it's not possible that someone scores more than 80% and they don't get an A. That's what we are saying is not possible. All right. So if sufficient condition hypothesis is false, we cannot say anything about the conclusion. Okay. Sufficiency does not imply necessity. Okay, so something is sufficient for something else does not mean this is necessary for this thing to happen. Okay, these are two different aspects. If something is sufficient for something else to happen, that something is not necessary for this thing to happen. This thing might be happening anywhere. Okay, are we good? Can you guys think of an example that sticks in your brain? Sports metaphor or something, yeah?
You can pass even if you score less than 80.
Yeah, you can pass even if you score less than 80, right? Because it's not necessary for you to score 80% to pass the course. Okay? The statement is not saying that. Any other examples? Here's an example, okay? If we are playing against an associate team, Babur will score a century. Okay? All right? So this is a sufficient condition that whenever we play with, I don't know, what's the latest team, I don't know, Nepal or something, then Babur is going to score a century. But it's not a necessary condition for him to score a century. He may still score a century against, I don't know, what else, Zimbabwe or something, right? All right? I don't know if that sticks in your mind. But again, so...
Not a good example.
Not a good example? Okay, I'm sorry about that, Babur fans here. Okay, what should I... Yeah, okay, find your own example. Or come up with an example and tell me. Did I hurt a lot of people here? Okay, sorry guys. My bad. Okay, come back to the greatest example. Okay, if you score more than 80, you will get to pass the course. If you don't, you must still pass the course. Okay, so that's sufficiency.
As another example.
Sure.
Babur will score a century against Australia, but Pakistan will not win.
Okay, right. So good. But write it in if then P then Q form. Right. So we are talking about conditionals, right?
If Babur scores a century against Australia, then
Yes.
Pakistan will win.
Then Pakistan will win. Or do you want to say then Pakistan will lose?
Anything can happen, sir.
All right. Okay. Cool. Right. If it sticks in your brain, go with it. Okay. Find a crazy example that sticks. That's very important. That's what I'm saying. If you stare at these statements all day, the only thing that's going to help is an example. Okay. Most of the time, examples distract you from the truth. They compartmentalize your thinking philosophy. But when you're talking about logic, it helps you kind of internalize the logic. Once you have internalized the logic, then you can throw away the examples. Okay? So that's why it's important to find an example that your brain will always connect to, right? Brain is all about making connections. Okay? All right. If an employee does not work overtime, we cannot determine whether they will get a bonus or not. And this is based on the example which says that if you work overtime, then you will receive a bonus. Okay. But so what that means is that working overtime is sufficient to get the bonus. Okay. But it's not necessary. Okay. That's the second part. I was supposed to say necessary somewhere on this slide. Oh, it's here. Okay. So to enter a concert, you must show a valid ticket. Here, valid ticket is necessary condition to enter the concert. Okay. So this is the if part to enter the concert, and this is the Q part. You must show a ticket. Okay. So Q part is necessary for P to be true. Okay. If you don't have a valid ticket, you cannot enter the concert. All right, moving on. This is, to access the app, you must know the correct password. Correct password, well, this Q part is necessary condition to access the app. Okay. इसकी जो false conclusion होगा, false conclusion would be that you don't know the correct password. Okay. If you don't know the correct password, you should not be able to access the app. Okay. So if you don't know the correct password, you cannot access the app. It's a must-have for the necessary condition. Questions? This is kind of written over what we were talking about for the last 5 minutes. Okay. All right. So here are a few other conditionals that we construct from a given conditional. Okay. Now we have a statement which is if P then Q. Now we can construct other conditionals from those conditions by using only the negation operator and switching things. Okay. So the original statement is if a person is a programmer, then they know how to code. Okay. Converse of this statement would be that if a person knows how to code, then they are a programmer. Okay. So if this statement were if P then Q, this statement would be yes. क्या होगा? Yeah. This is if Q then P. Okay. We have just switched the places of the two statements. Okay, so that's converse. Remember what converse is. Contrapositive is when you switch the places and also negate them. Okay, so if a person does not know how to code, this is the negation of Q part, then they are not a programmer. This is the negation of the P part. Okay, the inverse is where you just negate things. Okay, so if a person is not a programmer, then they don't know how to code. Okay. So everyone understands what a converse, contrapositive, and inverse is. Okay. Just to remember, मैं अपने ज़हन में ये करता हूँ कि inverse, in my mind, means negations. Okay. Converse means switching. Contrapositive means switching and negation. Okay. Contrapositive is easy to remember. Converse and inverse कभी-कभी अब भूल जाते हैं. Okay. I'll start by remembering the inverse means negation. Okay. Then converse is definitely switching. Some of these conditionals are equivalent to each other. Some pairs of these conditionals. Can you spot them? Contrapositive and inverse are equivalent. Absolutely not. No, they are not. They are not. I don't think they are. But let me have a look.
Inverse is the same as the original statement.
Sorry, what?
Inverse is the same as the original statement. Both others are.
What about you?
Converse and contrapositive.
Converse and contrapositive. I'm hearing all the wrong answers. There are about, 4 possible answers, and I got 3 wrong answers. Tell me. Sorry, what?
Original statement and contrapositive.
Original statement and contrapositive are equivalent. We'll see in a moment why. We'll prove it why this is the case. ओरिजिनल एंड कॉन्ट्रापोजिटिव आर इक्वलेंट. सो ओरिजिनल स्टेटमेंट के अंदर अगर आप उनको स्विच कर दें और उनको निगेट कर दें तो यू एक्चुअली गेट द ओरिजिनल स्टेटमेंट. यू विल गेट द सेम थिंग. ओके, contrapositive is equivalent to the original statement, and that means inverse and converse the same, because inverse and converse are, inverse is actually the contrapositive of converse, and converse is contrapositive of inverse, if you look at them. Okay, so if you look at, for example, let's look at inverse. Okay, inverse says if a person is not a programmer, then they don't know how to code. Okay, इसका contrapositive क्या होगा? इन दोनों को हमने negate करना है और इनको हमने switch करना है. Okay, इनको negate कर दें तो ये don't खत्म हो जाएगा. And I would have if they don't know how to code, then they are a programmer. Sorry, if they know how to code, then they are a programmer. That's converse. Okay. Awesome. For a moment, I'm gonna formally, so the thing is, formally to see why original statement and contrapositive are equivalent, you would have to do what? Make their truth tables. Make their truth tables and you'll know that they are equivalent on the paper. But before going there, if you look at this, what this thing is saying, a moment ago I said that Q is necessarily happening when P is happening. Okay? That's what I said a moment ago. If P, then Q is equivalent to saying that Q is necessarily happening when P is happening. Okay? What that means is that if Q is not happening, then what? Then P is not happening. Then P is guaranteed that it's not happening, right? That's what it means. That if right? What that means is that if Q is not happening, then P is not happening, and that's not Q, then P. Okay, that's the contrapositive. Okay. Once again, I said a moment ago that Q is necessarily happening when P is happening, which means that if Q is not happening, then you know that P is not happening, and that is the contrapositive. Okay, which means that these two statements are equivalent. Are we good? Questions? All right, we get another statement which is called biconditional. I don't know if we have truth tables for these, but I trust that if they are not, you should be able to construct them. Okay, so take this as a homework to construct the truth tables and be. Why do you have your phone on? Get out. Get out. What's your name? Get out. All right, don't do this, guys, okay? I give you a set of rules. I'll obey those rules, and I want everyone to obey those rules as well, okay? This bumps me out. All right, make their truth tables, okay? And confirm that original statement is equivalent to contrapositive and converse is equivalent to inverse, okay? Another conditional is called biconditional. Biconditional is just saying that if P, then Q, and if Q, then P, okay? What does that mean? If I have that if P, then Q, and if Q, then P, what does it mean? Yeah, so P and Q are equivalent. P and Q are so we don't say the word equal because P and Q would possibly be referring to two different statements. But what we say is they're equivalent, which means that their truth values are equivalent. When one is true, the other one is true. When one is false, the other one is false. Okay, so that happens when you have biconditional between P and Q. Consider a rule for a two-way ticket to a theme park. You can use the two-way ticket if and only if you enter the park in the morning. It's not a very good example. I'm looking for an example. If you find a really good example that I should put on this slide, send it to me. Is it same as conjunction? No, it's not.
Vertically.
Sorry, what?
What's the difference?
Between this and conjunction. So the difference is, for example, this part. Okay? So when both of them are false, the biconditional is true. Okay? Conjunction would be false. Okay? If you want to relate it, this is opposite of exclusive OR. Okay? Biconditional is opposite. Negation of, sorry, I should say negation of the exclusive OR. Someone had a question. Yeah.
Is it exclusive nor?
I don't use that word, but if you want to, go ahead.
Exclusive nor.
Yeah, it's the negation of exclusive OR. If there is a word for it which is exclusive nor, I don't mind. Go for it. Yeah. It's the negation of exclusive OR. Any other questions? Yeah. You want me to explain this again? Okay. So so we read this as biconditional or equivalent. Okay, which means that P and Q have the same set of truth values. Okay, that's the statement. Okay, again, remember this is a proposition. When I say that P biconditional Q, this is a statement. The statement itself might be wrong. Okay, the statement, what I'm explaining is the meaning of the statement. The meaning. This I'm gonna pick. I don't know this part. What else? Just pick one line. Just pick 2 points. Okay. What it's saying is pick any 2 points within that area and you connect them by a line segment. If the line segment is included in your area, then that shape is convex. Okay. So once again, pick any 2 points in the area and connect them by a straight line segment. Okay? If everything on that line segment is included in the shape, तो फिर वो shape convex होगी. Okay? Is this shape convex? A triangle? A triangle is always, pick any 2 points, you will still stay in the triangle, right? Is this half kind of circle also convex? Yeah. Pick any. Circle is always convex. This thing is probably not convex because if I pick a point somewhere here and maybe here, then I can draw a line segment that makes me go outside the shape. Okay, which means this thing is not convex. This thing is also not convex, right? Remember, there are points for which you stay in the region, but there are also points which require you to go outside. Okay, यहाँ पे there is no pair of points which require you to go outside to go from one to another. Okay, is this convex? This is convex. Pick any 2 points on this line, you would stay on this line. Okay, is this convex? So this is just 2 points. Remember I said pick any subset of, I'll define subset at some later point, but for now I'm relying on your high school knowledge. Pick any 2 points. Okay, so these 2 points are now my subset. Is this convex? Is it? No, it's not. It's not, because see, there are only 2 points which I can pick, and if I try to connect them, then I'm going outside these 2 points. Okay, is just 1 point convex? 1 point is convex, right? I can only pick that point twice and I stay there on that point. Okay, so this is convex. So what this statement is saying, that if I want to cover a convex area, think of convex area as, I don't know, an art gallery or a classroom, and I want to cover it with a camera that is 360. Okay, that can look all around it. Then one camera is enough to cover the whole of that region. Okay. So what this statement is saying, that if this is a convex area, I can pick 1 point and it will be able to look everywhere, right? And the second part is that so there are 2 parts to this statement. That is what it makes it biconditional. One is camera is necessary. The other part is the camera is sufficient. Okay, one camera is sufficient to completely monitor any convex region. One camera is necessary to completely monitor a convex region. Okay, you need a camera. अगर कोई कैमरा आपके पास नहीं होगा तो you won't be able to watch it. Okay, so one camera is necessary. That part is true. One camera is also sufficient. जो हमने अभी देखा. If you have one camera, you can look everywhere around a convex region. Okay, so this is biconditional and it's also true. Okay, questions? All right, so that was a little diversion. You'll pass the exam if and only if you are you have studied for at least 10,000 minutes. Again, it's a biconditional. It may or may not be true. The funny example. What's the funny example? You will become a master chef if and only if you can microwave popcorn without burning it. This is a biconditional. But it's not a true biconditional, right? Because one part is true. If you can become a master chef, then you can definitely, I don't know, microwave a popcorn. Okay? But if you can microwave a popcorn, that does not make you a master chef. Okay? It's a biconditional, which is not true. Any questions? No? All right, how much time do I have? Okay, I'm gonna stop here because I have one small thing to show you. सुबह मैं Twitter देख रहा था तो I saw something from Adil Najam, so वो मैंने कहा आपको दिखा देता हूँ. Any questions related to discrete? Anything you want to say? आज I want to make sure that everyone should be on Slack by 5 p.m. Okay, make it sure. जो लोग रह गए हैं प्लीज़ डू इट. अगर नहीं तो यू नीड टू फाइंड समवन टू मेक इट हैपन फॉर यू. रवीद है यहाँ पे, महरीन है, नरमीन, राइट? Narmeen, okay, Narmeen is here. I have trouble pronouncing her name. But find these guys and make sure that you are on Slack today, okay? All right, let me show you what I wanted to show you. It's not related to discrete mathematics, okay? Well, it talks about numbers, so it's somewhat related to discrete math, but so this is Pakistan's this year's budget. Can you guys see everything? Have anyone seen this before? Oh, you have not. So this is fun then. This is kind of distribution of major chunks of money, where the money is coming from and where the money is going. Okay. And I thought since you guys are going to be, I don't know, much more invested in this, so I would show it to you. So left ke upar, what you see is where the money is coming from. The right shows you where the money is going. Okay. जो चीज़ें मेरे लिए नोट करने वाली थी ना, थिंग्स आई नोटेड वर फ्यू. फर्स्ट ऑफ ऑल ये जो आपका डेट वाला पार्ट है ना, सो दिस इज़ द मनी जो हमारे पास नहीं है एक्चुअली, ये हम कहीं से ले रहे हैं किसी और से ना. सो देयर इज़ अबाउट 8,000 बिलियन रुपीज़ जो हमारे पास नहीं है लेकिन हमने उसको खर्च करना है, तो वो कहीं ना कहीं से हम लेके आएंगे. ओके, लोकल या फॉरेन कहीं से लेके आएंगे. एक और जो पॉइंट है देखने वाला वो ये कि हाउ मच वी आर स्पेंडिंग ऑन provinces. So this is what goes to provinces, about 7,000 billion. This is almost everything that's being spent on people. This is all. So जो आपके schools हैं, जो आपके hospitals हैं, all of this, all of the services that we provide to the public, that's coming from this. Okay, so ये जो कुछ यहाँ पे है उसका public से कोई ताल्लुक नहीं है. Okay, everything that comes to public is here. Most of it. Okay, बहुत limited चीज़ें हैं जो यहाँ से आती हैं. अच्छा, the most striking thing for you guys to note should be this part, the interest payments. Okay, this is the most we are spending on anything. Okay, we are getting this much loan, which is 8,000 or something billion rupees, and we are spending about 10,000 billion rupees in interest payment on the loan that we got in previous years. Okay, so that's compared to everything else. Look at the defense. We always talk about defense. I mean, it's a major chunk. I won't say कि इसको बिल्कुल negligible. It's not negligible, but compared to this thing, I mean, look at this. It's 2,000. Okay, what else do I want to point to? Yeah, we also talk about the running of government. Running of government costs us about 800 billion. I mean, compared to everything else, that's not much. If you were, for example, able to make this zero, this will not put any dent on anything in this budget. You know? I mean, it's not, again, it's not negligible. 800 billion is like, I don't know, $2.5 billion, right? It's still a reasonable amount of money. But for the whole thing, part of the whole thing, it's not that big. The most important part is somewhere here. Okay? Does anyone note anything else important here? मेरे लिए तो important part ये था कि आपकी जो सारा education का है ना, universities, schools, colleges, वो सारा यहाँ से आ रहा है और आपका hospitals भी यहाँ से आ रहे हैं, medicine भी यहीं से आ रही हैं, and this is it. This is everything you get. All right? Anything else? You guys noting from here? I'll share this picture with you. So this was created by Adil Najam. He's a professor in Boston University. He was actually the first, जो हमारा ITU का पहला convocation हुआ था ना, he was the guest speaker there. I think it happened 2018 or something. All right, that's it from my side. I'll see you next week. Meanwhile, keep up on the Slack. Okay? See you guys.